Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 4.2, Problem 4. This is Section 4.2, Problem number 4. It says consider the data, and we have, let's see, 1, 2, 3, 4, 5 x, y pairs. We have x is 3, y is 16, x is 5, y is 20, x is 0, y is 9, x is 2, y is 12, and x is 1, y is 10. And the question says draw the scatter diagram, find the linear regression equation, in other words, y equals a plus bx, predict y when x is 4, and then graph the linear regression equation on the scatter diagram. I have the scatter diagram set up a little bit. So, part A, draw the scatter diagram. What we want to do is first figure out how our number scale is going to want to run. So I have some evenly spaced marks, but we have to label that. So the biggest x value that I see that I'm going to have to deal with is 5. So I can even run, there's 10 marks here. I can run them 2 at a time. 1, 2, 3, 4, 5. So you'd have 1.5, 2.5. So that'll take me to the end. Now the biggest y value we have is 20. So we could run them 1 at a time for 20 little lines, but that's kind of goes beyond what I want to draw. Where I have 10, I'll just go 2, 4, 6, 8, and then the top one will be 20. Again, notice the x and y don't run on the same interval. That's fine as long as you label it clearly. And not everyone would draw it exactly the same way. You could have 4 different people with 4 different graphs that look different, but all 4 be correct. Some people would prefer to keep it simple and just run the x and y both 1 at a time and have it that way. And it'll change how steep your line looks, for sure. But as long as you pay attention to the scale, they'd all be okay, as long as they're labeled clearly. So the first one, x is over 3, and y is up 16. So there's 3 on my x, and then up 16. So there's the first point, 316. Then I have 520, over 5, up 20. The next one is over 0, up 9. So over 0, up 9. So I don't have 9 exactly on my number scale, but halfway between 8 and 10 you can figure is 9. And again, it's over 0, up 9. The next one is over 2, up 12. There's 2. And finally, the last one is over 1, up 10. So here's over 1, up 10. And you can see they don't fall perfectly on a straight line, but it's pretty close to straight. So that's part A. That's the scatter diagram. Part B, find the linear regression equation. Find the equation y equals a plus bx. So this is a multi-step process. The first step is fill out the chart. Your chart's going to be x, y, x times y, and x squared. So there are 4 columns to fill in. The first 2 you can just copy from the question. So the x values are 3, 5, 0, 2, 1. The y values are 16, 20, 9, 12, and 10. And now what you have to do is, for each row, multiply x times y. So in the top row, x times y will be 3 times 16. That's 48. The next row, x times y, is 5 times 20, which is 100. The next row, x times y, is 0 times 9. Careful, that's 0. You'd be surprised how many people have tried this problem. They put 9. Of course, 0 times any number is 0. The next row, x times y, is 2 times 12, which is 24. And in the last row, x times y is 1 times 10, which is 10. And then one more column, x to the second power. So make sure it's x that you're doing, not one of the other columns. So in the top row, x is 3. So 3 second power will be 3 times 3, which is 9. The second row, x is 5. So 5 second power, 5 times 5 is 25. In the middle row, x is 0. It's an easy one. 0 times 0 is 0. And the fourth row down, x is 2. So 2 second power, 2 times 2 is 4. And finally, in the bottom row, x is 1. So 1 to the second power is 1 times 1, which is 1. So step 1, fill out the chart, is done. We filled out the chart. There it is. Step 2, get a total for each column. So I have some of the math done out just so I can fill this in a little bit quicker. So the total of the first column, this one totals up pretty easily, is 11. The total of the y column, if you add all the numbers together, 16 plus 20 plus 9 plus 12 plus 10, comes out to a total of 67. The total of the x times y column is 48 plus 100 plus 0 plus 24 plus 10, which comes out to a total of 182. And finally, the x squared column, if you add 9 plus 25 plus 0 plus 4 plus 1, the total comes out to 39. So that's step 2, get a total for each column, and we did. Each column is total. We added them up. Step 3, take the totals that you get, plug them into the formula for B, and get an answer for B. So the formula for B is total of x times y minus total of x times total of y over n, and then the denominator is total of the x squares, where the second power is inside the parentheses, the total of is outside, then minus total of the x's squared. So you have the same parts, but the total of symbol now is inside the parentheses and the second power is outside. So the parentheses group it a little bit differently, which makes a difference, and there's an n under that. So that's the formula for B, which again, I never ask anyone to memorize. So start plugging in the values. So plug them in carefully. If you make a mistake, typically this is where it's made when you plug in the totals. So total of x times y is our x times y column. The total is 182. Minus, set up a fraction. Total of x first. So total of x is 11. Times total of y. Total of y is 67. Divided by n. N is how many data points you have. So if we count them up, you count rows in your chart, 1, 2, 3, 4, 5, or you could count the points on the scatter diagram, 1, 2, 3, 4, 5 points. Don't count the bottom row for totals. That's not data. That's computation that we put in. So n, number of points, is 5. So now in the denominator of this whole problem, we have total of the x's to the second power. Second power is inside the parentheses. So you do the second powers first, then get the total. So where we do the second powers first, then get the total, the answer comes out to 39. So this part of the formula, total of your x's squared is 39. Minus, now total of the x's squared again, except this time the total of symbol is inside the parentheses. So you make the total first, which is 11 in this case, then you're going to do second power. So we're going to have 11 to the second power. Also over n, so n again, how many data points, is 5. So that's how the formula fills in. This you want to do carefully. Resist the temptation to do some computation and some fill in simultaneously. You'll get most of it right, but you really need to get all of it right. So now that it's filled in, now we can start the math. So B equals 182, this will stay for a minute, minus, so let's do this multiplication, 11 times 67, and it'll have a 5 under it. So if I'm doing this right, it should be 637. I brought my paper. Let's see if I'm right. 737, so I did make a mistake. And then in the denominator, 39 minus 11 second power. So we'll do 11 times 11, which I know is 121. And that's also going to be over 5. So we did our multiplications. So the next thing I want to do is do the divide by 5s. So 182 will stay for a minute. Minus, so 737 divided by 5 is 147.4. And then in the denominator, we still have this 39 minus, so now that's going to be 121 divided by 5. I have the answer written in front of me here. It's 24.2. So what started off just a few lines earlier, looking like a mess, especially when you have the total of symbols, which do look intimidating, it's boiled down not too bad. So in the numerator, 182 minus 147.4 is 34.6. And in the denominator, 39 minus 24.2 is 14.8. And now this is not something that I could reduce in my head. So typically what you want to do is use a calculator. So you're going to do the numerator, 34.6, divided by the denominator, 14.8. And the calculator will do that for you. You get 2.337837838. Well, you don't need that many decimals. So I like to go 2 places after the decimal if they don't say anything specific outside of that. So let's call it 2.34. The third position out, the 7, is big enough to make this into 2.34. So in terms of looking for y equals a plus bx, b is 2.34. Now that would be a positive 2.34. So now that we have b, the next step in the process is take the answer for b, put it into the formula for a, and find a. So the formula for a is a equals total of the y values over n minus the b that we just found times total of the x values over n. B is a much easier formula to do. A is a much easier formula to do than B. So total of the y values, looking back at my chart, the total of the y values was 67. Divide by n, n is 5, again, n number of data points, minus b, the b that we just found from the previous work. So b came out to 2.34. That's b, 2.34. Times total of the x values. Again, as I look back at the chart, the total of the x column was 11 over n. N is number of data points, and that would be 5. So now that I filled in the formula for a, let's start doing the math. Let's do the divisions first. Let's divide out those 5s. So a equals 67 divided by 5 is 13.4 minus 2.34 times 11 divided by 5 is 2.2. So now at this point, a equals 13.4 minus 2.34 times 2.2. You have a subtraction and a multiplication that has to be done. And the order of operations require that you do the multiplication first. You can't do the subtraction first. Even though it's written first, you must multiply first. So a equals 13.4. Now when I multiply 2.34 times 2.2, I get an answer of 5.148. And when I subtract 13.4 minus 5.148, I get a is 8.252. And again, since I had been going to 2 places after the decimal, the third one out, the 2, isn't quite big enough to make it an 8.26. So let's say a is 8.25. And if you remember from before, b was 2.34. So the final step in the process of finding the y equals a plus bx equation or linear regression equation is write it in the form y equals a plus bx. So now at this point, the a is 8.25, so y equals 8.25 plus b is 2.34, and then the x stays. So that's the linear regression equation, y equals 8.25 plus 2.34 times x. So now that we found that, the next part of the problem, part C, says predict y when x equals 4. So we have predict y when x is 4. So we had y equals 8.25 plus 2.34x. So now instead of x, let's put in 4 because part C of our problem says predict y when x is 4. Now that we have that, again, you have an add and a multiply. You must multiply first. So y equals, leave the 8.25 for a minute, plus 2.34 times 4 is 9.36. So to finish my prediction, I have to do y equals 8.25 plus 9.36. So if I total that up, it comes out to 17.61. So predict y when x is 4. When x is 4, I predict that y will be 17.61. So the last part of the problem says graph the linear regression equation on the scatter diagram. So here's a scatter diagram. I want to graph y equals 8.25 plus 2.34x on this. And what that's going to do is it's going to give me the line that fits the best for the data points that I have. So that's a straight line. To draw a straight line, I need 2 points. One of them will be my prediction point. It said predict y when x is 4. So I said when x is 4, y will be 17.61. So there's 1 point on the line for sure. So let me put that on my scatter diagram. I'm going to put it on in a different color just so it doesn't blend in with all the other dots that are the same color. So if I go over 4, up 17.61, so between 16 and 18 is 17. Figure 17 and a half is 3/4 of the way. That's pretty close by to being over 4 and up 17.61. So I need a second point. I have 2 points, I connect them, make a straight line. So to get a second point, I can just make a second prediction, and I pick the x value. I mean, this particular problem told me to use x is 4, so I can put in, I don't know, x is 1 or x is 0, make a second prediction point and connect them, which would work pretty easily. But you always get a point on the line that is average of the x values for the x coordinate, average of the y values for the y coordinate. That's always a point on the linear regression line. And you might feel, well, that's more work. And if you hadn't already found a and b, it would be. But since we've already done the computation for a, average of the x values, that's total of the x's over n, and the y, average of the y values, total of the y values over n. That's how you get the average. We've already done that. So if I go back to my formula for a, average of the x values over n is 11 over 5 is 2.2. So the x coordinate of that point is 2.2. Oops. And now the y coordinate, average of the y values over n, we also did that. Here's total of the y values over n, 67 over 5, 13.4. So that's a second point on the line. Again, if it was a curved line, 2 points are not enough. Straight line, 2 points are enough. So what I'm going to do to get that second point is I'm going to go over 2.2. So this is 2.5. 2.2 by I is about 2 1/4. And up 13.4, so a little less than the 14. Maybe about here. So if I go over 2.2, up not quite 13 and a half, that'd be about right there. And now I have 2 points. I'll connect them. And that graphs my y equals a plus bx equation on my scatter diagram. So this line that I've drawn here, this is the graph of y equals 8.25x, 8.25 rather, plus 2.34x. And that's it.